Greetings and welcome to GILFORD'S lectures. So today we are going to be looking at a random question which was proposed to me by an MI engineering student. The velocity of a ship A relative to a ship B is 100 km per hour in a direction north 45 degrees east. If the velocity of B is 200 km per hour in a direction north 60 degrees west, find the actual velocity of A in magnitude only. We are given options A, B, C and D, so this question was actually an MCQ question. Let's move straight into the solution. The very first thing you want to do here is draw a schematic diagram to represent the information above. Since the velocity of A relative to B was at a direction north 45 degrees east, then we can draw this line. We are guided to draw this line as such, and this is the velocity of B, and it was equal to 200 km per hour. So this angle was the angle 45 degrees, and it was the angle north 45 degrees east, while this other angle was the angle north 60 degrees west. Hence, we can conclude that the angle beneath is 30 degrees, since the angle between these two axes is 90. The angle between these two axes is also 90. The angle between this axis and this other axis is also 90. And this axis and this is also 90. So the sum of these two angles is equal to 90. So if this is 60, then this is 60, then this is 30. So now the information represented on this diagram is exactly what we need to solve the question appropriately. Remember that this vector is the velocity of A relative to B, while this vector is the velocity of B, and their respective angles have been shown. So if we resolve the velocity of A relative to B along the vertical and horizontal component, for the horizontal component we are going to obtain 100 sine 45i, and for the vertical component we are going to obtain 100 cos 45j. And if we resolve the velocity of B for the horizontal component, we are going to obtain negative 200 cos 30i, and for the vertical component, we are going to obtain 200 sine 30j. So now we obtain the velocity of B to be the sum of its horizontal and its vertical component, and the velocity of A relative to B to be equal to the sum of its horizontal and its vertical component. So generally, the velocity of A relative to B is equal to velocity of A minus velocity of B, and if we make velocity of A subject of formula here, then we are going to obtain velocity of B plus velocity of A relative to B, or velocity of A relative to B plus velocity of B. So you can therefore see that the velocity of A becomes negative 200 cos 30i plus 200 sine 30j plus velocity of A relative to B, which was given by 100 sine 45i plus 100 cos 45j. If you bring your I components together and your j components together, you obtain this expression here. And if you isolate your i's and j's as such and replace cos 30 by root 3 on 2, sine 45 by 1 on root 2, sine 30 by half, and cos 45 by 1 on root 2, and do your evaluations properly, you are going to obtain velocity of A to be equal to 199.1, which is approximately equal to 198, and hence you can conclude that the option D is the correct option.